Hello, myself Jinay Pagariya, and today we, the students of Vishwakarma Institute of Technology, are going to discuss the topic Hierarchical Memory System. What is a hierarchical memory system? A hierarchical memory system refers to the organization of different types of memory in a computer system, where each level of memory has different characteristics such as speed, capacity, and cost. The computer memory can be divided into five major hierarchies that are based on use as well as speed. A processor can easily move from any one level to some other level based on its requirements. These five hierarchies in a system's memory are register, cache memory, main memory, magnetic disk, and magnetic tape. Now let's discuss the different levels of memory. The different levels of memory are register memory, cache memory, main memory, magnetic disk, magnetic tapes. Registers. These are the smallest and the fastest type of memory that is built into the processor and used to store data for immediate use by the processor. Cache memory. It is a type of high-speed memory that acts as a buffer between the processor and the main memory, holding frequently used data for quick access. RAM, which is also called as main memory. It is the primary memory used by the processor to store data for processing. It is faster than disk storage, but it is volatile, meaning that its contents are lost when the computer is powered off. Disk storage, for example, hard disk drive. It is the main long-term storage for a computer used to store programs and data when not in use by the processor. Disk storage is slower and less expensive than RAM, but it provides much larger capacity.
Hi guys, my name is Shivam Padalkar and I will be telling you how to access the data. So, accessing the data. In a hierarchical memory system, each level of memory is used to store different types of data based on their expected use, with faster, smaller memory being used to store frequently used data and larger, slower memory being used to store less frequently used data. This enables the computer to quickly access the data it needs while also maximizing the use of available memory resources. Moving on to the next slide. Examples of hierarchical memory system. Personal computers. Most personal computers have a hierarchical memory system that includes processor, registers, L1 and L2 cache, and RAM as the main memory, with disk storage used as long-term storage. Next point is servers. Larger servers systems often have more complex hierarchical memory system, including multiple levels of cache and high-speed memory such as NVRAM, in addition to main memory and disk storage. The third one is mobile devices. Mobile devices such as smartphones and tablets typically have a hierarchical memory system and includes processor registers, R1 and R2 cache, and low power RAM as the main memory, with flash storage used as long-term storage. The fourth one is gaming consoles. Gaming consoles often have a hierarchical memory system that includes high-speed memory such as GDDR6 to support fast and smooth graphic processing, in addition to main memory and flash storage for long-term storage.
Hello, myself Yash Pahade, and I am going to tell about the process of hierarchical memory system. Data input. Data is input into the computer system either through user input or through a program or application. Data processing. The processor retrieves the data from memory and processes it as needed. Data storage. After the data has been processed, it is stored in memory for later use. Memory allocation. The data is stored in the appropriate level of memory based on its expected usage, with frequently used data stored in faster, smaller memory, and less frequently used data stored in larger, slower memory. Memory access. When the processor needs to access the data, it first checks the cache and main memory to see if the data is stored there. If it is, the processor can access the data directly from the faster memory without having to wait for it to be retrieved from disk storage. Data retrieval. If the data is not found in the cache or main memory, it is retrieved from disk storage and loaded into the appropriate level of memory. Data output. After the data has been processed and retrieved from memory, it is output as needed, either to the user or to another program or application.
I am Niranjan and I am going to explain importance of hierarchical memory. Improved performance. By storing frequently used data in faster, smaller memory, the hierarchical memory system helps to reduce memory access time and improve overall system performance. Cost savings. By using larger, slowly slower memory for less frequently used data, the hierarchical memory system allows for cost-effective use of memory resources. Energy efficiency. By using low-power memory in mobile devices, the hierarchical memory system helps to conserve battery life and improve energy efficiency. Scalability. The hierarchical memory system can be easily scaled to accommodate changing memory requirements, allowing computer systems to grow and adapt as needed. Support for high-performance computing. The hierarchical memory system is an essential component of high-performance computing systems, such as supercomputers and servers, providing the memory resources needed to support large-scale data processing and analysis. Overall, the hierarchical memory system plays a critical role in optimizing the performance and cost of computer systems, allowing them to support a wide range of applications and use cases while conserving energy and resources.
Hi everyone, this is Palaash Padman, roll number 66, and today I'll be talking about memory standards. According to the memory hierarchy, the system supported memory standards are defined as: on level 1 we have register, on level 2 we have cache, on level 3 we have main memory, and on level 4 we have secondary memory. The size of a register is less than 1 kilobytes, of a cache less than 60 megabytes, main memory is less than 16 gigabytes, and secondary is greater than 100 gigabytes. Implementation of a register is via multiple ports. Cache is by on-chip or SRAM, main memory by DRAM, which is a capacitor memory, and secondary memory by magnetic disks. Access time of a register is 0.25 nanoseconds to 0.5 nanoseconds. Of a cache is from 0.5 to 25 nanoseconds. Main memory 80 nanoseconds to 250 nanoseconds. Secondary memory 50 lakh nanoseconds. Bandwidth of a register is 20,000 to 1 lakh megabytes. Cache 5,000 to 15,000. Main memory 1,000 to 5,000. Secondary memory 20 to 150. Registers managed by compiler, cache by hardware, main memory and secondary memory by operating system. Backing mechanism of a register is from cache, of a cache is from main memory from secondary memory, and secondary memory from IE. In conclusion, the hierarchical memory system helps to reduce the memory access time by having smaller, faster memory closer to the processor, reducing the number of memory accesses that need to be made to retrieve data. For example, if the processor needs to access data that is stored in disk storage, it will first check if that data is stored in the cache or main memory. If it is, the processor can access the data directly from the faster memory, without having to wait for it to be retrieved from disk storage. In summary, the hierarchical memory system provides a flexible and efficient way to manage memory resources in computer systems, allowing for optimized performance, reduced access time, and cost-effective use of memory. Thank you everyone. Please like and share and subscribe.